For section 7 of chapter 3, it covers orbital diagrams and electron configurations. We aren't going to focus on orbital diagrams, so it's in the title of your book, it's in your book, but we're not going to focus on those. We're going to focus on these electron configurations. I forgot to mention in the previous section, but for chapter 6 section 6 and section 7, your book goes into detail in other areas than I emphasize. So for both of these sections, I don't recommend that you read the book. Okay, the pictures are awesome. They will help illustrate what I'm talking about, but the book itself kind of emphasizes different areas. So again, I'm not recommending that you read the book. Just look at the pictures and use the information that I give you in the notes. So we're going to look at electron configurations. Okay, electron configurations look like this here. This is a full list of the electron configurations. Your book and other chemistry classes want you to kind of construct this from scratch. I'm going to actually show you how to use the periodic table to write them out. And that will help us kind of simplify some of our discussions for the end of chapter 3 and into chapter 5. What electron configurations do is they tell us what shaped orbitals our electrons are in, and that will help us discuss how the electrons can interact with each other. A great periodic table is found at this link here, and I'm going to kind of go back and forth between that periodic table. It definitely has more information than you would ever need in a periodic table, but it's going to definitely help us see these electron configurations a little easier, I hope. What we're going to be talking about is a very, very simplistic look at these electron configurations. There's definitely more details that we could go into, but for the level of our discussion, we don't need to know a lot of the specifics. We can just get a very broad picture of electron configurations. So, next page of notes that we'll be working with is the one that looks like this, and I'm also going to look at that periodic table website as well. So a little bit of moving of the camera. I apologize. So here is that periodic table. And if I make, oh, this is not focusing. Let's try and make it focus. That's as good as it's going to get. If you make the periodic table larger, okay, it has a lot of information on there, but I want it to fit on the video, so we're going to look here. I don't know if this is going to work. Well, let's give it a try. If we look at orbitals here, okay, if I move my cursor around the periodic table, notice that kind of our picture up in this area here changes. Okay, over here is what the orbital looks like. Okay, and we can change different orbitals. Don't worry about that kind of stuff though. Okay, what I want you to focus on is this stuff right here. This is the electron configuration. If we start over here at hydrogen, okay, and we're going to rewrite this on our paper, so if you keep, I know you guys can't really see this, but it's more kind of the point of seeing how things are working. But we have, it says 1s, and then it has in the superscripted on the right hand side a 1. Okay, hydrogen has 1 electron. That electron lives in the 1s orbital. Okay, so s is a spherical shape. These blue squares right here are the orbital diagrams. So your book also covers these, but we just want to focus on the electron configurations. If we moved to helium, so I've just moved my cursor to hit over helium here. Helium has an additional electron. So that electron, the second electron, lives also in the 1s orbital. So we list this as 1s2. So remember, each orbital can hold 2 electrons. So helium has 2 electrons in its s orbital. Going to the next element on the periodic table is lithium. So again, I've just moved my cursor down here to lithium. Lithium, now ignore this because it's getting a little complicated. Remember, all we are interested in this over here is we have 2 electrons still are in that 1s orbital, but we ran out of room. We couldn't put a 3rd electron in there, so we had to go to the next orbital available to us, which is the 2s orbital. And that would then be 2s1. So lithium has 3 total electrons. 2 of them are in the 1s orbital. The 3rd is in the 2s orbital. As we go to the next and the next and the next element, we're just adding 1 more electron. So for beryllium, puts a 2nd electron in the 2s orbital. So we have 2s2. Moving to the next element, we have boron. So I've moved right there. We have 2 electrons in the 1s, just like we did before. 2 electrons in the 2s, just like we did before. Now we put the 5th electron that boron has in the 2p orbital. That's the next available orbital. For the remaining elements on this table, on this row here, from carbon, nitrogen, oxygen, fluorine to neon, we're adding 1 more electron in those p orbitals. Okay? And there were 3 p orbitals, 3 of those dumbbell shapes. So we have a total of 6 electrons that can go in those. So we went from 2p1 for boron, 2p2 for carbon, 2p3 for nitrogen, 2p4 for oxygen, 2p5 for fluorine, 2p6 for neon. We go to the next element, okay, we go from neon to sodium, we go down a period in the periodic table. So down here we have sodium, it's 1 more period down. You'll notice that we added a new number out in front. We're now to the value of 3. So our electron configuration stays the same when we went from neon to sodium. We just added 1 more electron. So we have 3s1. Moving to the right to magnesium, so I've just moved right there, I have 3s2. And then we move all the way across here to aluminum. Okay. Aluminum now will start adding into the p electrons, and it's in the same row, right, the same period of the periodic table, so it has the same number out in front. So we have 3s2, 3p1. Silicon, 3p2 ending, phosphorus, 3p3, sulfur, 3p4, chlorine, 3p5, and argon, 3p6. Next row, our next element, we go down to potassium. It's a row down, it's a period down the periodic table, so we add a new number. We have 4s1 and 4s2 for calcium. Then something funky happens. When we go to, what is this? Scandium, that's probably better. Scandium here, okay. It's in the same period as potassium and calcium, but it's in this new kind of block, this new section here, okay. That new section is a new shaped orbital. It's the d orbitals, okay. And the d orbitals are special. Their number goes down here. So over here you'll notice it went from 4s2 to 3d10. We're not really going to talk about these d orbital electrons because they do some funky things that we don't really need to talk about. These are also the transition metals, and we'll learn in chapter 5. They kind of play by their own rules. We'll talk a little bit about the rules, but for what we're discussing here, we don't need to know the specifics of what's going on in this section. Okay, we just need to know that it is 1 less value than what potassium and calcium were at. Okay. So we move across here, we skip that middle section to gallium. And out here, we've now moved into the p orbitals. So we have 4p1, moving over to germanium, 4p2, 4p3, 4p4, 4p5, 4p6. So you kind of get the gist of what's going on. Okay. The section down here, the lanthanide and actinide series, remember these get interjected right there. These electrons here are the f orbital electrons. Okay. So our periodic table is kind of split apart into the type of orbitals we have. We have the s orbitals, we have the p orbitals, the d orbitals, and the f orbitals. In the next video, I want to go through this electron configuration again, and we're going to draw these out. So we'll actually kind of see it, hopefully a little bit clearer, a little bit more in focus.